Hello, I welcome you all to this another interesting screencast, and the problem reads the curved rod has a radius of 5 feet. If a force of 60 pounds acts at this end as shown, determine the moment of this force about point C. In the second case, determine the smallest force F that must be applied along the rope in order to cause the curved rod, which has a radius of 5 feet, to fail at support C. This requires a moment of M equal to 80 pounds-feet to be developed at C. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have case number 1 where I've been asked to find moment about point C, right? And this is going to be equal to R cross F, okay? So we have F here. This is the F, okay? And then we have two R's that can give us the same answer. We have, since we are finding moment about point C, we can use this R, which is the moment arm. We can also use this R. Okay, so this is RB, and then RCB. This is RCB, or this one is RCA. So therefore, RCA is equal to the force AB. This is also equal to RCB cross FAB. So both can give us the same solution or the same answer. This is in case 1. Case 2, we have been asked to find the smallest force that must be applied so that this rod fails, and we've been given the failure moment, which is 80 pounds-feet. Again, this is the same thing, just MC, which is moment about C. Let's say we have picked RCA as our lever arm, then cross AB. But in this case, MC is given as a scalar, as a magnitude. So what we need to do now is to find F. So we need to write F using the unit vector. So we'll have RCA times, let's call it just F times the unit vector AB. Alright. Okay. So once we find this, we are going to do the cross products, and then we're going to use Pythagoras to find the magnitude. So we'll have a moment mx I, okay, plus my j plus, so imagine we have this moment there, okay, mzk, okay. These are just magnitudes, sorry, these are magnitudes, so we don't need to do this. All right, so we're going to have something like this. Then we'll say 8 now finally will be equal to square root over, because this part here will be equal to this part, so these are equal, right? These are equal. All right, and then once we have this, then we'll say mx squared plus my squared plus mz squared. Right, and since this will have an f in it, then we'll make f subject to the formula, then we'll find the value. Basically, this is what we intend to do. Okay, let's start the work. So what we need to do now is we'll choose this as our moment arm, and then we'll call this as our RCA. Okay, so now let's find out the coordinates. We need coordinates. Of course, this is our reference. So coordinates for A is going to be equal to let me start from here. A is going to be equal to, in the X it is 0, because if you've seen A is just in one plane, which is the YZ plane. So in the x is 0, then in the y it is 5 sine 60. Then in the z is 5 cos 60. Therefore, this gives us as a 0, comma, let me just write it somewhere here. So this is going to be equal to 0, comma, 5 sine 60. This gives us a 4.33, comma, cos 60 is 0.5, therefore this is just 2.5. So found A. Let's find B. B is equal to, let me move this, I move this, I move it to there. Okay, so let's find B. B is going to be equal to, in the x it is a 6, in the y it is a 7, that's B, in the z it is 0. Right, and then C, it is just 0, 0, 5. Great. So let's find RAC. We need this as C minus A. C minus A, 0 minus 0 is just 0i. 0 minus 4.5, 4.33, that's minus 4.33j. That's AC. Sorry, we don't need AC, right? We need RAB. Okay, because we need a unit vector there. Sorry, B minus A. That is 6 minus 0, that's 6i. 7 minus 4.33, 7 minus 4.33, this is a plus 2.67j. And then we have 0 minus 2.5, that's a minus 2.5k. And then the magnitude of this, we need that because we need a unit vector there. That's 6 squared plus 2.6 squared plus 2.5 squared, square root of that. So we have a 7.02. Alright. This stuff is clustered here. Let me move it down. So say RAB, the magnitude is equal to 7.02. Alright. Then let's find RCA. We need that. RCA as A minus C, A minus 0 minus 0, 0. 4.3 minus 0, that is 4.33j. Then 2.5 minus 5, that is minus 2.5k, right? So 4.3 minus 0, that's 4.3j. Then 2.5 minus 5, that is minus 2.5. Alright. So what we need now is to convert this force into a force vector. So say FAB, this is for the first part, FAB is equal to the force itself, which we are just going to say FAB magnitude times the unit vector AB, right? Then this is going to be equal to 60 times a unit vector. We've not even written down the unit vector. Let's write it down. So unit vector AB is equal to RAB divided by the magnitude. Okay, and this is equal to RAB. Found RAB is 6I divided by 7.02 plus 2.67J divided by 7.02 minus 2.5K divided by 7.02. Therefore, the force vector AB is going to be equal to the magnitude force AB times the unit vector AB, and this is equal to 60 times 6I plus 2.67J minus 2.5K divided by 7.02. Right. So there we go. Let's now just create a boundary here, like so. Okay. Let's finish this part. Therefore, the force itself is equal to FAB is going to be equal to, we need to multiply now, 6 divided by 7.02 times 60, so this gives us a 51.28I plus, this one was 6 divided by 7.02 times 60, that's 51.28. Then 2.67 divided by 7.02 times 60, we get a 22.82J minus 2.5 divided by 7.02 times 60, this is equal to 21.37K. Okay, so there we go. We have the force vector. So I want to write down in advance the force also, the unknown force in terms of F. So the unknown force in terms of F, we write it as just F is equal to, this is for the second case, this is going to be equal to the magnitude itself, which is just F, the magnitude itself, which is just F, times the unit vector, times, so the magnitude F times the unit vector AB. Alright, we know what the unit vector is. We can multiply this and it gives us, we're going to have 6 divided by 7.02, so this gives us 0.85 0.8547F. I'll lengthen it like that, plus 0.85447, okay, F Then 2.67 divided by 7.02. This is 0.3803 F. Then minus 2.5 divided by 7.02. This is 0.3561 F. Okay. So 6 divided by 7.02, 8547. 2.67 divided by 7.02, 3803. 2.5 divided by 7, 3561. Right. So we have this general expression. This one we need for case 2. This is for case 2. All right. Now let's start the cases. I think we've developed everything that we need. So let's say case 1, which is 4 dash 43. 4-43. So this is quite direct. We're just finding moment about point C. So that's MC. Vector moment MC is equal to RCA, okay, cross FAB, okay, and this is equal to, let's use our tool. We use our tool for doing the cross product. If you don't like this, you can do the cross product directly, but this makes the work easier. You don't have to punish yourself or invent a wheel. There is already a wheel invented for us. RCA. What is RCA? We found it somewhere. RCA, yes, there it is. It is here. So let's just plug it in. We don't have I, so it is 0. Then J, it is 4.33, and then K is minus 2.5. Then the force AB, we have a 51.28, and then we have a 22.82. Then we have minus 21.37. Okay. Minus, that is 37. Let me remove this. Okay. 37. All right. So there we go. Let's do the multiplication. So we have I, that's a 4.33 times minus 21.37 minus 22.82 times minus 2.5. So we get a minus 35.48 minus J, so 4.33 by minus 21.37, then minus 2.5 by 22.82, 35.48. Then J is going to be just a plus, which is 2.5 by 51.28. So this we get a 128.2, right? Okay, J is 0, then minus this, which is a plus 128. All right, then plus K, K is 0 minus 51.28 by 4.33. Okay, 51.28 by 4.33. So we get a minus 222.04. So MC, moment vector MC, is equal to minus 35.48 I minus 128.2 J minus 222.04 K, and all this is pounds feet. Okay, and then the magnitude of this is just going to be equal to 35.48 squared plus 128.2 squared plus 222.04 squared. Okay, so this gives us a 258.84 pounds feet. 35.48 squared plus 128.2 squared plus 222.04 squared. 258.84 pounds feet. Alright, so let's go to the second case, which is case 4-44. Okay, so this one we've already been given the moment. So what we are saying is basically what we are saying is MC, okay, is going to be equal to MCXI plus MCYJ plus MCZK. Okay, all right, and then later on we know that this MC and then this is supposed to be equal to the force hold on, supposed to equal to RCA cross FUAB. Okay, and we found this already, if you remember. This is what we found here. So this part here is what we found. We found this. This is the one. Let me just point it. This is the one we found. Alright, we found this. So this is what we want to do. And then later on we know that MC this is just equal to magnitude of this MC is equal to 80 pounds feet. So we already have the solution to this, so we just want to work out this now. We are working it out in reverse. Alright, so RCA, let's do the, so we'll say RCA cross FUAB, which we already found. This is going to be equal to, plug it in our tool. We're going to plug it in our tool. Okay, let's plug it in our tool. For this one is supposed to be a little bit, because there are a lot of decimals there. Alright, so RCA is equal to 0 here, then there we have 4.33, then there we have a minus 2.5, and then we have FUAB. This is equal to 0.8 8547F. Okay, then this is equal to 0.3803F. Okay, and then this is equal to minus 0.3561F. Okay, let me just move this to somewhere there like that. Right. Okay, and therefore we'll say this is equal to RCA cross F times UAB is going to be equal to we do the multiplication, we bring it a little bit down there. So this is going to be equal to I. We are multiplying minus 0.3561 times 4.33. Okay, and then minus 2.5 times 0.3803. Okay, so we have a minus 0.5912 F. Okay, minus J, let me just multiply it again, 4.33 times minus 0.3561 minus 2.5 times 0.3803. Okay, 5912. Then minus J just minus 2.5 times 0.8547, right? So this becomes a plus, which is a 2.11368. Then plus K. Okay, so 2.5, this is minus plus by 0.8547, 2.1368. Then K, that part goes, then we have a 4.33 times 0.8547. So this is minus 3.7009 F. There are all these F's here. Okay, let me just write down the F there. There's an F here, and then there's also an F here. Alright, so this is the expression that we found. So what we need to do now is to find the magnitude, and all this is equal to MC. Okay, and therefore this MC, working it out as a magnitude, which is equal to 80, we are saying is equal to square root, right? Let's work it out. So this gives us minus 0.5912 F squared plus minus 2.1368 F squared plus minus 3.7009 F squared. So we square everything so that we later on find what this gives us. So 80 therefore is just going to be equal to Let's square this. 0.5912 squared squared 0.5912 squared plus 2.1368 squared plus 3.7009 squared. All right, and then square root of this. There we go. So this is going to be equal to 4.3142 f, and therefore f is just going to be equal to, let's find what f is. F is just going to be equal to that's 80 divided by answer gives us 18 gives us 18.54 pounds. Okay, so therefore F minimum is going to be equal to 18.54 pounds. Let me create a boundary here. There's a boundary here. Okay, like so. Right. Let me now outline the solutions, final solutions. Let me just move this a little bit down like so. Right. So this we have this equal to 18.54, and then we have the vector there and this magnitude of moment about point C equal to that, okay, whose magnitude is 258.84. Okay, so this is about it. And I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.